A vision of tomorrow's manufacturing. Products finding their way independently through the production process. In intelligent factories, machines and products communicate with each other, cooperatively driving production. Raw materials and machines are interconnected within an Internet of Things. The objective: highly flexible, individualized and resource-friendly mass production. That is the vision for the fourth industrial revolution. A look back at history. At the end of the 18th century, the first steam engines and the intelligent use of hydropower revolutionized production. The late 19th century saw the rise of electrical engineering and mass production. The first moving belt conveyor was used as long ago as 1870 in the slaughterhouses of Cincinnati, Ohio. In the mid-1970s, electronics and IT began to expand rapidly into industry. Siemens developed the first SIMATIC. Production became increasingly based on computer-assisted controls. The fourth industrial revolution is still a vision. Experts believe that it will only become a reality within the next 20 years. In intelligent factories, everything is interconnected wirelessly. At the German Research Center for Artificial Intelligence in Kaiserslautern, this future can already be experienced right now. Research is underway here into exactly what the industrial production of tomorrow will be like.
Fabriken werden zukünftig aus Bausteinen bestehen, aus smarten oder intelligenten Bausteinen, wie man es nennen mag. Vergleichen wir das vielleicht mal so ein bisschen mit einer Lego-Steinwelt. Das heißt, wir haben standardisierte Bausteine, die wir hoffentlich relativ einfach zusammenstecken und zusammensetzen können. Jeder dieser Bausteine hat bestimmte Funktionalitäten und wir können sie zukünftig in einem solchen fabrikinternen Internet dann kombinieren.
A bottling plant for liquids, set up together with Siemens, is used to demonstrate the most important components of the intelligent factory of the future. Each bottle contains an RFID chip storing a precise description of how it has to be processed. Which liquid, which lid, and which label. At each station, the bottle communicates directly with the machine, telling it how it has to be processed. At the end, a computer checks whether the bottle has actually been produced as desired. Factories with networked machines and products are already in existence today. In the future, however, these hitherto self-contained systems will be connected together in a comprehensive network. All devices, machines and materials will be duly equipped with sensors and communications technology and connect to each other. These systems are known as cyber-physical systems. The highlight is that they communicate with each other and also control each other cooperatively.
Wenn Sie sich das Thema Industrie 4.0 angucken, dann basiert sie ja auf der Logik dieser Cyber-Physical Systems. Das heißt, Sie haben autokrate selbst arbeitende Systeme, die sich optimieren und sich gegenseitig austauschen. Und dadurch letzten Endes Produktion optimieren.
Ja, die Vision sieht so aus, dass wir ein Internet quasi hinunterziehen bis auf die unterste Ebene. Das heißt, jeder Sensor, jeder Aktor wäre damit quasi ein Teilnehmer eines Internet der Dinge. Jedes Gerät hat damit eine eigene IP-Adresse, ist damit adressierbar in diesem Netzwerk.
For the customers, this means tailor-made products at relatively affordable prices. For industry, it means highly flexible mass production that can be rapidly adapted to market changes. Because in the future, product life cycles will be even shorter. Another reason why it's increasingly important to depict engineering across the entire life cycle. Maintenance, for instance, is planned in from the very start.
Wir haben ja bereits in den 90er Jahren mit Totally Integrated Automation entsprechend ein Setup gewählt, wo unsere Produkte und Systeme sehr gut miteinander kommunizieren können.
At Corporate Technology in Princeton, a cyber-physical control is being researched even today. The vision, the control, and all linked sensors are connected to the Internet.
One potential scenario is enabling the PLC to react to utility pricing information in building automation. We can enhance PLCs to use simulation to calculate how much to pre-cool a building, with the ultimate goal of turning off the cooling system during peak times.
But that's just the beginning.
We've prototyped capabilities in a PLC to access big data in cyberspace in real time. And we've also enabled a network of PLCs to connect to a dynamic simulation of the entire physical process.
Siemens is shaping the future of industry. Connecting the real with the virtual world of production is making it possible to enter entirely new dimensions in quality, efficiency, and flexibility. The company is well prepared for Industry 4.0.